Alrighty, welcome to Tag Day 9, where we are going over area of composite figures, or in other words, 711C. And so we're going to be talking about our strategies on how we can break apart these shapes and then find the individual areas. I'm sorry, 7.9C, 7.9. And so if I look at this shape, it looks kind of like an ice cream cone. And they want us to find the area of this composite figure. Sadly, if I look at my reference chart, there isn't a formula for an ice cream cone or this specific kind of shape, however you would name it. So we will need to split this shape into smaller and recognizable pieces that do actually have formulas. So let's think about what shapes we actually do see. So if I get my highlighter, I definitely see a triangle here, right? It's just facing upside down, so I see a triangle. And then I also see that we have a semicircle. Okay, so how do I know this is a semicircle and not a normal circle? Well, it doesn't go fully around, right? 360 degrees. It was like cut in half. Therefore, we have half, or a semicircle. And so how would this area of a semicircle compare to the area of a full circle? Well, instead of finding the area of the entire thing, I would just find the area of half of it. So we see that this isn't a full circle, and so since we only see half, we're going to have to think about when we find the area of an entire circle, how we would then find half of it to get the answer of this semicircle. Okay, so I know that my shape is composed of a semicircle and a triangle, so I will go ahead and draw this out in my plan so that I can break it up into what I'm going to do first and then what I'm going to do second, and then how I'm going to add both areas up to find the total area. So here is our plan. So on my formula chart, I see that the formula for the area of a circle, so let me get my highlighter, the area of a circle is pi r squared. So I will go ahead and write it below the drawing of the semicircle. Okay, so that's the closest we have, a equals pi r squared. But I remember that I'm not going to find the area of the entire circle. I'm only finding half. So how would I then represent that in my formula? Well, I will need to cut it in half or divide by 2. So now that I've kind of created my own formula to find the area of a semicircle, what would be the formula for the area of a triangle? So if I look on my formula chart again, I see that it is a equals 1/2 base times height. So I will write that below the triangle, and there's nothing new that I need to add to that because that will get me the full area of the triangle. Okay, so now that we have both formulas, we can go ahead and start substituting to find the area of this composite shape. So let's go ahead and make sure that we have the correct measurements. So let me see for our semicircle. We already know well, first, we do know the measurements of the triangle, which is 16 centimeters across. So I'll put that here. And 22, oops, why is it lagging? 22 centimeters like tall as the height. So let me add that. Okay. So we now have the base of the triangle, which is 16, and then we have the height of the triangle, which is 22 centimeters. So I can actually substitute those in for the base of 16 and the height of 22. Okay, so now that I've labeled them both as the base and height, let's look at the semicircle. So for the semicircle, I see that the only measures that I have are the diameter across, which is 16 centimeters, right? This is the diameter, which is 16 centimeters because it cuts the circle in half, but our formula doesn't need the diameter, it needs the radius. And so for the radius, we know that it is always half of the diameter. So if I cut this in half, this would be the radius. So what is half of 16? Well, I know that is 8 centimeters. And if I wasn't quite sure, I could go over to the side and divide it by 2. And I see, sure enough, that it is 8 centimeters. So now that I have the radius, let's go ahead and substitute that into our formula. So pi 8 squared, and don't forget we have to divide by 2. Alrighty, so now that we have all of our measurements and we filled in our formula, we can now begin solving our formulas. So if I start with, let's just kind of scroll down. If I start with the semicircle, I see that I have 8 squared, and I know 8 squared is written as 8 8. So let me just write that in here so I don't forget that it's 8 times 8. And then once we're done, we will divide by 2. So what is 8 times 8? Well, I know that is 64. And then I still wrote everything else again right below it so that I can get ready for the next part. Now I see that we have pi and we need a number for pi. So if I look at our reference chart, I see, oh, actually we don't have it snipped here, but the pi symbol on the bottom of our reference chart, since you'll have the full thing, oh goodness, is 3.14. Right, that's the approximation we typically use. So because we're in review time, we actually can go even simpler and use 3 for pi, just so that we can approximate and get a close estimate of what our answer will be without any sort of decimal errors. And so I can go ahead and replace pi with 3 times 64 divided by 2 so that we can get an approximation. So 64 times 3 is 192. And then remember, that is the area of the entire circle, so we need to cut it in half, drawing our seats so that we can find the exact amount, which is 96. So the area of the semicircle, I'm putting the S there for semicircle, is approximately, so we show approximately with that little wavy symbol, 96 centimeters squared. Now, are we done finding the area of the composite shape? No, we are not, because we only have found the area of the semicircle. And so now we need to go into finding the area of the triangle. So we've already substituted our base and height. And so now we can start multiplying this out. So typically, because these numbers are so big, I like dealing with the 1/2 because I know multiplying 1/2 is the same thing as dividing by 2. So write that note down to yourself. And so because both of these numbers are even, I know I can cut them in half pretty easily. And so I'm going to go ahead and do that with the 1/2 times 16, or in other words, what is half of 16? And I know that's 8. Let's bring down the 22, and all we're left to do is multiply 22 times 8, which is 176. So the area of the triangle, T for triangle, is 176 centimeters squared. Now, are we done with our problem? Nope, we have the area of the semicircle, we have the area of the triangle. However, we have one more step to do, and that is to add them together. So we're putting the pieces together as they are shown in the picture above, and we see that the total area of the composite shape, or of our ice cream cone, is 272 centimeters squared. So let's stamp that when we are looking at composite shapes, the first thing we need to do is see what shapes do we have within it that we can break apart and create our plan. Once we've created our plan, we need to look at our reference chart so we can write out the formulas and then begin substituting and solving. Once we have finished finding each of the pieces, we will then add so that we can find the total composite shape. Let's try some more on our own.